So we'll go ahead and get started. We are talking about passing by reference, parameters that are passed by reference. So if you guys remember from last lecture, we were talking about wormholes, we were talking about portal, and we talked about call numbers to check out books or find books in the library. All right, any questions? Yes? Nobody knows. Okay. You guys ready? Hello. You guys ready? All right.
Yeah, you must have really cool stuff.
All right. So you guys ready? Are you guys ready? All right. Let's double check.
You know what? Should I get one of those portal shirts for yesterday's lecture?
Well, I had one student who said a better analogy.
No, I mean.
Yeah. No, the portal shirt.
No, I mean just like it's got the mouse going in one, coming out the other.
Yeah.
The other side.
Oh well. But one student actually said there's a better analogy. It's a Stargate. Passing by reference is a Stargate. You walk into the gate, you walk out of the other side, and you can be half a galaxy across. Well, depending on whether you lose the power of the Stargate, you can actually go across a galaxy.
That's a cool show.
Which one?
Oh.
So anyhow, that's where we stopped last time. We were talking about passing by reference. I think I created one program but did not have time to finish it. So that's what we'll do today, is to finish up that demonstration. All right, so let's see. Factorial by val by ref. I think we went through this one. This one was traced.
Yeah, we did that.
Yeah, we did that one. But I think I actually wrote a different program that I did not trace.
No, we did that.
Okay, we got, let's see, look at the date modified. The last one is that one. Okay, so we did verify. We did
them all.
We did them all. Okay. Okay, do you guys have any questions? Anything I can answer?
Just checking.
Okay, well, let's kind of focus on the material in the class, for now. Okay. All right. So what we'll do is what we're going to do today is to point out the limitations of passing by reference. As it turns out, passing by reference is not really, it's good, but it's kind of cumbersome at the same time. Okay. So what we'll do is not to talk about pseudocoding for the time being, but instead I'm just going to show you an example and say that well, this is the restrictions that we are dealing with right now, and is that a reasonable restriction? Okay. Now you guys all know about the addition operator, right? 4 plus 5 is 9. You know the multiplication operator, 7 times 8 is 56. And you also know subtraction and division and so on. But what if I tell you that the only thing you can do with the sum, the product, the difference, and the quotient is to store it to something else, to store it to a variable? That's the only thing you can do with it. Okay, would that be a restriction? Would that be a significant restriction as to how you can express a arithmetic expression?
No.
Yep.
Or storing the number or the result?
The result. Yeah, the only thing you can do about the result is to store it into a variable. Now you can use the variable later. Okay, nothing prevents you from referring to the variable later on, but the only thing you can do is to store it somewhere. In other words, if I put this restriction on, then it would not be possible. Okay. You cannot evaluate something that looks like this: 4 plus 5 times 2 plus 3. That is not possible because the only thing you do is to compute the sum first, put it into a variable, and you compute the product between 5 and the sum of the previous calculation, and then you can compute the sum between 4 and the product of the previous calculation. So let's see what we are trying to illustrate here. Okay, what if you can only store the result of an operator, but you can refer to any variables in any expressions? Okay, so what we need to do in this case is we have to use a variable, let's say x, to store 2 plus 3, and then we can say x gets 5 times x, because x already has the sum of 2 plus 3. So now now x is the product of 5 and 5, which is 25. And now we have to say x gets 4 plus x to finish the operation. In other words, we can do it. It's not a problem. But is that what you want? It's not very convenient, right? You can see that we can do everything that we could do before with this, but it's just not convenient. But the problem is not just that it is not convenient, it is also error prone, because if you compare this, a single evaluation like this, you are also leaving more room for error. Because when I can only use, when there's a restriction, what if I use the wrong variable? No tool can ever tell me that I'm using the wrong variable. So I can make mistakes and not realize that I had made the mistake. Whereas if I use the normal approach, and I can actually use the result of an operator as the value for the next operator, it makes things so much easier to understand. It is very handy to be able to utilize the result of a calculation immediately without having to store that into some place first and then refer to that variable later on. Is that going okay? Now, why do you think I brought this point on? What does it have to do with the parameters that we have talked about?
It's probably the restriction that we have.
Is the restriction of the by-ref parameter. Yes, you can use a by-ref parameter to pass information out of a subroutine, but you have to store it somewhere. Okay, whenever you pass by reference, you always have to pass a column to the parameter that is passed by reference. You cannot just say, oh, this subroutine is going to compute blah, 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 and I just want to utilize that immediately in another subroutine as a parameter of another subroutine. We don't have the mechanism to do that.
Oh, sorry.
Go ahead. Oh, okay. So what we'll do today is to talk about a mechanism that will allow us to do something like this. Okay? It's called a return value. Now, the concept of a return value can be both simple to understand and also difficult to understand. Because what we are now doing is we are changing. You guys doing okay? All right. So what we're doing is we're changing the way we invoke subroutines. Okay? When we invoke subroutines, in the past, we always return to where? What is the return address?
Follow it after.
We're always going to the line following the invocation, right? So what are we going to do now? Well, let's take a look. Let's take a look at a test program like this one. And not this particular one. That's not a real program, so we'll get rid of it. Oh, why did I have this? Oh, that's from another class. Never mind. All right, so we'll go ahead and take a look at a program like this. And I'll start with something that is really, really simple. Okay, and I'll start with define sub. Okay, does anyone know any really obscure language that you think the rest of the class would not know?
Gibberish. Gibberish.
Gibberish. Okay, we'll just say gibberish. Okay, so in gibberish, okay, this means 5. Okay, that's gibberish. This is the word of 5 that represents the value 5 in gibberish. Okay, so we're inventing a language and say this is this means 5. So what I'll do is I'm just saying that in this particular subroutine, we just return the value of 5 and define sub. Okay. So this is pretty much as simple as possible as a program that I can write that illustrates the concept of a return value. All right. So now what do we do? Well, we try to use it. Okay, let's see what we can do to utilize this. And I will just use a very simple program to illustrate it. We'll say that x gets the result of the invocation of IAIH. I just punched some keys on the keyboard. Okay.
Monkey banging keyboard. Monkey banging keyboard.
Yeah. Not very random though. Let's see. At least it's kind of pronounceable. EI. Yeah. Oh, whatever. Okay, so this is my program. This is a very, very simple program. But what it does is to illustrate the concept of how do we return a value from a subroutine, how do we utilize the return value of a subroutine, okay? And it will change the way we look at subroutines, from what we already know. So we'll go ahead and save the file first, and then we'll continue to trace it. So we'll say this is return value 1, because we'll have more programs to illustrate the concept of returning values. Okay, here's a new window for the trace. And as it turns out, it changes the way we do our traces completely. We have line number, and then we have our global variable x. X is still a global variable in this case. The precondition is we don't know anything about x. We don't need to know anything about x because the first line, the only line of the program, is going to store a value into variable x. Okay. So here's line 4. When we invoke line 4, now we have a problem with the concept of a return line number. Because when we say return line number, it just tells us which line to go back to. But in this case, invoke IAIH, okay, which means 5 in gibberish, is going to give me a result that I can utilize for the rest of line 4. Can anyone tell me what are the 2 components of line 4 just by looking at it? The subroutine is 1, subroutine call is 1, and then
the assignment statement.
The assignment statement. Now, which one do you think I should perform first? Should I perform the assignment first, or should I perform the subroutine call first?
You have to do the subroutine call.
The subroutine call first.
To fill the variable with the added.
Exactly. So the question now is, how do I represent it? Because if I use return line number just like before, what am I going to say here? Am I going to say return to line 4, or am I going to say return to post? If I return to post, that means as soon as the subroutine is done, I would not finish the assignment operation. If I say return to line 4, that means I'm going to invoke the subroutine again, because it doesn't tell me what else on line 4 do I have to finish. So that means this representation using just a return line number is no longer sufficient. It was okay before because we don't have to return to the same line to finish up some unfinished business. But now we do. Okay? So what I do is instead of using return line number, I just say it's return information. It's information to help me to continue execution after the return from a subroutine. Okay, are we doing okay so far? So all we're doing is, we need more information now. It's not just the line number. It looks like this. So now we have to say when the subroutine is done, we have to return back to line 4. But not only are we returning to line 4, we also have to remember what else on line 4 we are going to do. What else we have to do on line 4 after the subroutine call is we have to finish the assignment operation. But what is this question mark doing here? Well, it's a placeholder. Okay, it's basically a placeholder so that we can use the return statement to fill up that placeholder so that we can continue with the assignment operation. Are we kind of doing okay with this, conceptually? Okay. Then we continue into the subroutine. In this case, it's just line 2. Now line 2 says return 5. Return. Now in this case, the word return is used universally across all practical programming languages. C has return. Visual Basic does not use the word return, but it has a concept of returning. Java has return. PHP has return. Perl has return. I don't think Python uses the word return, but it has a concept of return as well. Perl does not use return either, but it has a concept of returning a value. Okay. But in this case, return 5 is not going to change the flow of the program per se, but what it does is it specifies what should go into the question mark. So in this case, the value 5 should go into the question mark. So in the trace, we copy and paste the return info cell, and then we change the question mark to 5, just like that. Are we doing okay so far with the effect of the return statement? All it does is to find the question mark in the return info cell, replace that with whatever value you're specifying on the return statement, and that's its job. It's done now. And then we go to line 3, which is the end of the subroutine, and that will do exactly the same thing as before. it reminds us that we have to continue execution on line 4, but not only that, line 4 now looks like this. Now that is also important. Oops. Now that's going to be really loud in the recording, so you might want to take note that about 15 minutes into the recording, crank the volume down because it's going to break your speaker.
Or blow your eardrums if you're wearing a headset. Or blow your eardrums if you're wearing a headset.
If you have a big speaker, then it might do some. Your speaker may bounce around a few times. I don't think anyone's going to listen to my lecture in a car, with those, really big subwoofers. So I don't have to worry about the rattling sound.
I do that all the time.
You do?
Driving down the road.
Do you have a 200-watt sub?
No, I don't.
500?
I was joking.
You should get one. Awesome.
All right. So now that we are done with this, we will deallocate the column that we allocated for the return info. So we'll go ahead and do the usual thing and just indicate that this column is now deallocated. Now we're back on line 4. What are we going to do on line 4? We can carry out the rest of the statement, right? We can carry out the rest of the action, which is storing the value 5 into X. So now X, which is column B, is updated with a value of 5, and we are done. Are we doing okay with this concept? This is a brand new concept, and it modifies how we look at subroutine calls. Is that okay? You feeling fine with this? Okay, let's save this file first, and then we'll do another example that that is really kind of boring in a way, but it is also not so boring in some other ways. We'll go
Does that have references to Portal? Does that have references to Portal?
I'll have to think of one that references Portal. But Portal has no equivalence of returning a value. That's kind of like a different thing. All right, so here we have define sub. We'll just say add, okay? Add has 2 parameters, because when you add numbers, you usually add 2 numbers. So we have byval x, byval y, and the only thing it does is to return x plus y. And define sub, and we'll just we'll work with this particular example. But instead of storing the value into a global variable, let's go ahead and print it. So we'll say print invoke add, and then we can say 4 specifies parameter x, and we'll say 10 specifies parameter y. And here is my second program. It is a little bit more complicated than the first one, but really not by much. The only difference is now we have parameters in addition to a return value. But those 2 concepts they're orthogonal, which means you can have one without the other and vice versa. All right, so let's go ahead and trace this particular program. And once again, we don't need any comments because there are no conditional statements to evaluate. There are no loops. So we start with a precondition. This time, there are no global variables. So the precondition really has nothing to say because there are no variables in existence at this point. Are we doing okay so far with that? Okay. The first line, the only line that I have to execute outside of the subroutine is line 6. Line 6 is going to invoke, well, let's see. Let's take a look at line 6 and see what it does. What do you think line 6 should do in terms of the ordering?
Invoke first, then print.
Invoke first and then print. Okay, very good. So that means when I invoke add, when I have to remember where to go back to, I have to use the same trick as the previous example. Okay, I have to remember that I'm going to go back to line 6, but I also have to remember what else on line 6 do I have to do in order to finish that line. Is that right? Okay, so we'll go ahead and try to express that. So this time we use return info as well. And this time the return info says we have to go back to line 6. But when we get back to line 6, we will have something, a value to print. We don't know what the value is. We are leaving a placeholder right now and say that, okay, hopefully the subroutine will figure out what the question mark should be when it's done. But at this point, we don't know what it is. We just say that when we get back to line 6, we will have a value to print. And that's what we need to do when we get back to line 6. The rest is really the same as any normal subroutine. We have a parameter x, we have a parameter y. They're both passed by value, which means they are copies of the original expression. So x is basically a copy of the value 4, and y is a copy of the value 10. Now we have all the columns set up. And then we continue execution in the subroutine, line 4. Line 4 is pretty easy. Return x plus y. So just like with an assignment statement, you have to evaluate the expression first. The expression is x plus y. X is a parameter. It has a value of 4. Y is a parameter. It has a value of 10. 4 plus 10 is 14. So that means we are actually returning a value of 14. But whenever we return a value, all we are doing is to copy and paste the return info cell to basically say, oh, now we know what the question mark is supposed to be. It is supposed to be 14. But I don't do any printing at this point. The return statement does not execute the statement inside the return info. All it does is to specify what the question mark is supposed to be. Do we understand that concept? We do not execute a statement. We just clarify what the question mark is supposed to be. Yes? Yeah, we do. Yep. So we'll add a column later. All right. So now we go on to line 5. Line 5 is just the end of a subroutine. It has to do two things. One is to use return info to tell us that we have to go back to line 6. And then the second one is to deallocate all the columns that we have here. So we'll go ahead and indicate that these columns are now gone. And now we're back onto line 6. So as you told me, we have to use a new column because we have to indicate what we're printing on line 6. But when we get back to line 6, the point is it now knows what value we are supposed to print. We're supposed to print a value of 14. Okay, so that's pretty easy. So in column A, I just have to say this is comments, and we're printing a value of 14. When that is done, then we get to post, and the program is done. Are we doing okay so far with this example? Which is pretty much the same as the previous one, except this one takes parameters in the subroutine call. We doing okay? All right, so now we are going to crank up the difficulty level one more time. Return value 2. Now we have return value 3, which looks almost identical to the first one in terms of the subroutine itself. We have add 5val x, 5val y, return x plus y. This part is identical to the previous sample program. Okay. Any questions I can answer? Any questions I can answer? Okay. All right, so this time we'll make it a little bit more fun. We'll also use a print here, and then we'll say invoke add. But instead of just saying, adding a constant to a constant, we're making this a little bit more interesting. We have another invoke add here. Okay, so this one has 2 going to x, 3 going to y. And then the result of this invoke specifies parameter x. And then we just have 4 to specify parameter y. So now we have a slightly more interesting case. Okay? Do we know how to deal with this sort of thing?
Inside out.
Yep, from the inside out.
Yes.
Yep. If you already know how to deal with parentheses in a normal expression, you know how to deal with this. Okay? All right, so let's go ahead and give these line numbers. But what is interesting is if you look at the number of columns it's going to use, what is your guess? What do you think the number of columns we have to use in this case? Let me just pull up the previous example first so that you can have a comparison, or at least have an estimate first. This is the previous example with only one add. Okay, there's no nested adding. It takes up all the way up to column E. So what do you think would what would be the columns we have to use this time now that we have an add inside an add?
8.
Up to H, yeah.
We use up to column H because F, G, and H are the 3 more columns, or do you think we're going to stay the same as this one? Well,
I think you're going to move farther out to the side.
well, we'll take a look, okay? Because there are different opinions, and only one is the right answer. The right answer is the behavior of the program, of the machine. When you actually write this code and have it run on the computer, that quote unquote is the right answer. So we'll go ahead and trace this one, and you'll be. I don't think you'll be surprised by the result, but I think you will gain a little more insight or a little better understanding of the concept of returning a value in this case. So I have to arrange it like this because this line is really long. I really can't display it side by side conveniently. All right, so now we have comments because I have a print. Comment.
Oh my God.
We have line number, and we have a pre. There's nothing to say in the precondition because I don't have any global variables anymore. So we'll go start with line 6, just like last time. We start with line 6. The question now is, I know that we have a return info because in order to finish the operation of line 6, what do we have to do first? We got 3 potential operations to choose from. Which one do we have to do first?
Innermost.
The innermost invocation of add. Okay. All right. So that means we are dealing with. Okay. If I go back to here, that means we are dealing with. I'm just going to highlight the portion that we are dealing with this time. This is what we have to deal with this at this point. Does that make sense? Okay. It's an invocation of add. We have to pass a value of 2 to x, a value of 3 to y, and whatever value it returns, we'll use it to specify parameter x for the other invocation of add. Is that making any sense? Okay. But how do we specify the return info in this case? In other words, we kind of know that we have to go back to line 6. We also know that. Oh, okay, I used the wrong cell here. Okay, we know that we have to go back to line 6. We know the print is not done yet, so the print has to be on the return info cell to remind ourselves that okay, that is not done yet. We still have to remember to do it. But what else have we not done yet by the time we return? The outer invoke, right? So the outer invoke add is not done yet, but by the time we are done with this invocation of add, it would have given me a value to specify parameter x, and 4 is just a constant till you got to parameter y. So that is how the return info cell should look like in this particular case. Are we doing okay so far? We are still doing the evaluation from the innermost part of the parentheses, exactly the same way as you would normally do with a regular expression. However, when we express what else we have to do on this line, we have to remember to put all the components that is not done yet, and make sure they are all on the return info line. Is that okay? In other words, we only replace the quote-unquote active invocation with a question mark. Everything else, we just copied and pasted. Okay? Yep.
So it kind of acts like a loop in that sense then?
It kind of acts like.
A loop, we're going to go through and do the inner info.
It's not a loop. No, this is not a loop because there's no condition to specify when to stop. This is simply, order of operation. What operation do you perform first, and then it provides you with a result so that it enables you to perform the next operation and the next operation. So we are really just making sure that the order of operation is correct, and also the fact that we are using the result from an earlier operation so that we can utilize the same value for a later operation.
Okay.
Okay. So now we go to, this is done, the return info cell is done, but we do have to make sure that we remember to specify parameter x and parameter y. Since this is the innermost invocation, 2 specifies x, and then 3 specifies y. And if I want to make it look a little bit better, you can just kind of resize the columns. It's fine. Okay, we are not going to run out of columns or space to display columns in this case. Then we get into the subroutine. The subroutine is really simple. Line 4 is going to return the sum of x and y. We know x is 2, y is 3, so the return statement is actually returning a value of 5, and therefore we take the return info cell, copy and paste it, and then we change the question mark to 5. Are we doing okay so far? Now, have I done anything differently compared to the previous 2 programs? Nope, they're still the same thing, right? I'm still doing exactly the same thing as the previous 2 programs. Then we go to line 5. Line 5 has 2 things to do. One is to remind me where to go back to continue execution, and the second thing is to deallocate the columns that we allocated for this particular invocation. So we'll go ahead and strike through these. Oops, strike through single, and now we are back to line 6. When we get back to line 6 now looks like this. Right? Because we have just resolved the value of the innermost invocation of add. Are we done? Can we print?
No.
No. What do we have to do now? The other invoke add. Okay, so we'll go ahead and deal with that one. And if you want to, you can actually usually just copy and paste it. But you have to remember the invocation, the active invocation, the one that we are performing at this point, you have to take that and replace it with a single question mark. Because the question mark is a placeholder for the return value for this particular invocation. We also have this is return info. We still have to reallocate columns D and E for x and y, but this time x has a value of 5 and y has a value of 4. Is that part okay? Should we stop here a little bit and make sure we understand how x and y gets the 2 columns got reallocated, but this time the values become 5 and 4. 5 came from the previous invocation of add. 4 was just specified as a constant 4 here. But we did not use 3 additional columns. Why do you think we just used the same 3 columns as the previous one, even though this time we have a nested addition?
Because we had already deallocated it.
Right, because we only deal with 1 at a time. So by the time we deal with the outer add, the first one is done already. So we could reuse the same 3 columns. That is why. All right. So now that we are done with this part, we go into the subroutine. Go to line 4. Line 4 says return x plus y. X this time is 5. Y this time is 4. 5 plus 4 is 9. We are returning a value of 9. All right, fine. We just go ahead and return the value of 9. Replace the question mark here with the value that we are returning, and we are done with the return statement. Then we go to line 5. Line 5 does the same thing as kind of last time. It tells us that we have to go back to line 6, but line 6 now looks like this. Okay, so we have to go back to line 6 at this point, and then after that we have no use of these 3 columns anymore, so we deallocate these 3 columns. And now we are back to line 6. But line 6 now is really just print 9. So we'll go ahead and perform the operation, printing 9 to the screen or the printer or whatever output device you want to connect it to. And we're done with this. Are we doing okay with this particular example? Don't you think this is a pretty long and tedious way just to say this? It's really just computing 2 plus 3 and then use that sum to add to 4 to it. That's all it's doing. But we are using the concept of a subroutine to express the same kind of expression. So this is a good place to kind of take a pause, take a breather, so that we can, for people who are interested, you can pay attention. For people who are not so interested, you can just kind of, not care about this part. When we use expressions like this one, okay, I'm just going to copy and paste this one. This is how we have been expressing numerical expressions since kindergarten. Okay, we use the infix notation. This is called the infix notation. Why do you think it's called the infix notation instead of prefix or postfix? Because the operator is between the two values that you have to operate on. Okay, so this is called the infix notation. What do you think would be a prefix notation? What do you think prefix would mean in this case?
So you'd have like
You specify the operator first, and then you specify the values that it has to operate on, right? So in this case, in the prefix notation, it will have a plus first because the outermost operation is an addition. What is it adding? Well, it's adding 4 and the result of a multiplication. So then you specify the multiplication, which is multiplying 5 and the result of an addition. The last or the innermost addition is an addition using 2 and 3. This is called the prefix notation.
you don't need to separate them with a
Well,
comma
it depends on who you are, okay? It sucks only because we are used to the infix notation. Okay? This is the same thing about, why do we feel binary numbers are so difficult to deal with? It's not because binary numbers are really more difficult to deal with. They're easier to deal with. It's just because we are used to base 10s. Okay? We have been using base 10 for the past 20, 30, 40 years, and changing the number, the base, to base 2 is a big change of what we are used to, and that's why we do not like it. And it's the same thing here. The prefix notation would actually make perfect sense if that is what we were taught from an earlier age. Okay? Well, the only downside of the prefix notation is it has a lot of parentheses. Okay, and that's exactly how Lisp programs are written. Okay, Lisp programs uses the infix notation for everything. Your code, your while loop is an infix notation. Your conditional statement is an infix uses the infix notation. Your subroutine definition uses the infix notation, and expressions uses the infix notation. Okay, so Lisp programs are pretty foreign to most people. And if you want to take a quick look at a Lisp program, we can just look for Lisp sample program. Come on, anytime now. Okay, we'll just go ahead and let's see. Well, there we go. That's how Lisp programs look like. Lots of parentheses. Okay? And that's why certain editors that we use, especially for Lisp programs, they will auto match parentheses. When you close a parenthesis, it will indicate which parenthesis is closing. And it becomes very essential when we're doing stuff like that. Well, fortunately, you are going to learn how to program in C and not in Lisp or Scheme, which is a dialect of Lisp. All right, but there's yet another. Oh, okay, that's interesting. Okay, but there's yet another notation. What do you think is the last notation? Yeah, this is prefix, and then the other one is postfix. Okay. Suffix is the same thing, but we call it postfix and not suffix. But you got the right concept. Now, suffix notation is even more strange. Okay, stranger, more strange. Okay, but that's another thing, because in English there's no true regularity. There's no solid rule that applies to everything. There are always exceptions to the rules and stuff like that, but making it one of the more interesting languages to learn. Yep.
How about even more stranger?
Even more stranger. In Chinese, we have a phrase to indicate, comparative, the concept of more or less. So you just, prefix, an adjective with that particular phrase, and then you have the more, the effect of more. It'll be pretty hard to make a new character every single time when you want to modify the meaning of when you want to modify the use of that character. We have what about 2,000 already, so we don't need any more.
Yeah.
All right.
One question: How do you use a computer then? There's only so much space on the keyboard. You don't have a.
There are about 13 or 14 really popular input methods.
Wow.
So it depends on whether you use the whether you use pinyin, which is pronunciation based input method, or whether you use the shape method to input the characters. Now when you use the shape, it also some would use the strokes, like what stroke goes first, what is the second one, and some would use pick the four corners of a character to encode the character. And then with the pronunciation one, then you can divide it into three main categories, because you have mainland China pinyin, you have the Taiwanese, I think it's called Juyin, and then you have the Cantonese own pronunciation method. I think within Cantonese it has different ways of encoding pronunciation as well. Yeah. And then if you use the stroke method, then you have the mainland China simplified Chinese characters, or you can use the conventional the complicated Chinese characters. So they are also different.
Wow.
Yeah.
I feel sorry for anybody trying to use a computer over there.
Well, that's why C is specified in just simple English words.
Yeah.
Do, while, if. We don't even have else in C. Well, we do have else. We don't have then. We don't have then in C. All right. So getting back to the notation method here. Now infix is what we are used to, but it has problems. Okay. The problems with infix is you have to use parentheses sometimes to indicate which operation has to go first. Right? I mean, when you read your math equations, or when you take physics, many times you have to use parentheses to help organize. Okay, within this expression, what operators has to be evaluated first? We have some implied ordering, like multiplication goes before addition and stuff like that. But in some cases, you still have to specify the order by using parentheses. Prefix always uses parentheses, so there's no way to get around parentheses in the prefix notation. Suffix sets we don't need, or postfix says, we don't need any parentheses, because we specify the numbers to operate on first, and then we specify the operation. Okay. In other words, if this were a real language, you specify the objects and the subjects, and then you specify the verb. Okay. And English is for the most part an infix language, because you have subject, verb, object. Right? But this is actually, subject, object, verb. Okay? So instead of saying, tag, tag throws a marker, it says, tag a marker, throw.
So you have to wait till the end
to specify the operation.
Yeah.
Okay, so let's take a look at how this expression is going to be expressed. Okay. Now let's just say that we don't want to change the order of the number, the introduction of the number. So we want to introduce 4, 5, 2, and 3 in exactly the same order as this. Okay. So what you do is you specify 4, and then you specify 5. But then you don't specify anything else, because we are not ready to perform the add yet. Okay. So we just move on, and we just say that 4 and 5 are now remembered, but I don't know what to do with them just yet. Okay, and then we say 2. Well, we don't quite know what to do with 2 yet. Now we introduce 3. Now we know something, don't we? Okay, because the last 2 numbers that are specified, 2 and 3, I should add them. Okay, so you specify add in this case, plus. Now this is where the magic happens. When you evaluate 2 plus 3, it will give you a 5. But the 5 is going to be to replace the 2 and 3. So now you end up with actually just 4, 5, 5 as the numbers that you can operate on. Okay, so what do we do with the 5 that is the result of this? Well, we're going to multiply that with this 5. So then you specify the multiply operator next, and then you specify the plus operator last, because we are taking the result of this entire thing, and we want to add 4 to it. This is called the postfix notation. Does anyone have an HP calculator or know someone, an old engineer with an HP calculator?
You're talking about reverse Polish notation?
Reverse Polish notation, RPN. That's exactly how RPN works.
Huh.
Yep.
Actually, it's interesting.
How many people have an Android device, cell phone or tablet or whatnot? Okay, if you have an Android device, you can actually play with this and impress your friends, the geeky ones only, using this program. It's called RealCalc. It's an Android scientific calculator, and it has a RPN mode. It has the usual algebraic mode using parentheses and whatnot, but it also has an RPN mode. So if you are bored and just say, oh, how do I enter this, big, long, huge equation in RPN? This is it's a good toy. It's an interesting toy.
I'm guessing you can't use that in regular math classes or anything.
I think you can. You mean, like, would the teacher let you use it?
Yeah, that's what I'm getting at. Because,
There's no real line, between a calculator and an Android device anymore. Your TI calculators are completely programmable. You can find programming kits and you write any programs on your TI 89 or 88 calculators. Your Android cell phone, you can download and install an app and turn it into a scientific calculator. I really don't think there's really a line anymore. The line is really just a pretense.
Internet
it's
access
the
basically
radio.
is the line.
It's the radios.
The radios.
So I can call someone and have them tell me the answers,
Mm-hmm.
and I can't do that with the regular calculator. That's why they won't let you use a cell phone as a calculator.
Yeah, but TI-89 calculators also have infrared communication.
Do they really?
But you're limited to direct line of sight.
You just need bigger and more powerful infrared diodes.
Yeah, well, you could bounce it off the ceiling if you really wanted to.
Professor, can I use this battery pack with my calculator?
Okay.
Why do you need a battery pack this big for a TI calculator?
The battery burned out. The old battery burned out, and this is what I got to replace it with.
And what is that big thing sticking out of the front of your calculator, right?
Extra battery.
That's the part of the mod.
There's a little glow. You guys know that infrared diodes are not exactly invisible. They actually have a very low, kind of deep red glow, because they can't really they cannot just focus the frequency to the invisible part. So there's always a little bit of spillover into the visible part. So your teacher will be asking, why is your the TI calculator glowing a little bit there? And then you can put a relay, device, at the window, so the signal can go outside.
What you just need to do is do an infrared to Bluetooth crossover.
Yeah. But as a professor, the best way is not to tell people not to do it, or to jam it. The best way to do it is to have your own device outside of the classroom to feed wrong answers back into the class. Sure, I'll play along. I'll take it as a challenge. So now you guys will have to think of authentication techniques to make sure that the answer comes from a authenticated source and not your teacher pretending to be one of your friends,
And
right?
at that point, you've probably done enough work that you could have just studied for the test.
Oh, people who can figure that sort of thing out, you're just doing it for the challenge. Yeah.
It's true. But the thing is, once you figured it out, you can sell those modified calculators.
No fun in studying for a test.
And you can jack up the price in the middle of the test too.
Yeah.
The first 5, are free.
No, I'm just talking about open up like an Amazon little store in their marketplace and sell them.
This is bad. I don't like the direction of this. And most of this is for me. That's the part that I don't like the most.
Oh yeah, that's true.
All right, but getting back to this one
Your
here.
math class.
Now getting back to here. Now this is a computer science class, computer information science class. So why do I even bring this up? I mean, why is this even relevant? Most of you are not going to turn your calculator into RPN mode. Although older engineers, engineers who are probably in their 40s or 50s right now, RPN was the only way they know how to use with a calculator, because back then there were no TI calculators. All scientific calculators were HP, and HP calculators only use RPN to enter expressions. Why do you think RPN is used? Is it because it is natural? People feel it's more natural to do it that way. Why?
Probably the easiest way for the computer to understand it.
It makes the computer easy to understand, because if you think about the computer who has which has to parse this expression, the logic to parse the meaning of this expression is actually not that simple. Okay, meaning when you encounter these symbols, what does the program internally has to keep track of in order to figure out the meaning of this expression? This is easier. Infix is actually easier to parse because it is actually a whole lot more regular compared to infix notation. There are no special consideration, no priority ordering and stuff like that. But this one turns out to be the easiest. In other words, back about 20, 30 years ago, when calculators are very limited in terms of how much programming you can put onto a calculator, this turns out to be the simplest input method from the perspective of the calculator, and that's why they used the postfix notation on older calculators. Okay, but this also relates to something that you and I know and use every day. How many people use PDF documents? Okay, on a daily basis, right? How many people have actually looked into the quote-unquote source, the actual content of PDF files? Okay, what does it look like? Gibberish. Well, it has some weird characters, but what PDF really is are instructions to tell a PDF reader how to draw objects, like where to put the fonts, where to put a vertical line, where to put a horizontal line, and all kinds of stuff. But that specification is actually using the postfix notation as well. So when it wants to draw a circle, it would input like the coordinate of the center of the circle, and then maybe the radius of the circle, maybe the thickness of the line, and the shape of the line, and then circle is the last one. So you specify all the parameters, and then you specify what are you going to do with those parameters. So RPN, or the suffix notation or the postfix notation, has been around for a long time, and computer science people like it because it makes the logic of parsing or understanding that particular notation is a lot easier than the alternatives. Okay. So that's obviously it's not going to be in the test, but I just think that since this is a computer information science class, this would be an interesting topic. Some of you may be interested in this. All right. So now that we are done with that, let's go back to factorial. Okay, we're going to finish factorial using the concept of a return value, but it's going to make the program both simpler, more elegant, and also, at least for the time during this class, maybe more difficult to understand. Okay, so we'll go ahead and take a look at our factorial program, but this time completely written using without using any variables whatsoever. So go ahead and deal with that again. So we'll say define sub, just like factorial, but this time since I'm just going to use f because we are not going to have. I want to make it short because we'll run out of room on the line. Okay, so we'll say by val n. In other words, n just specifies which numbers factorial do I want to compute. That's the input to this particular subroutine. I don't have by ref anymore. Instead, I'm going to use the return concept to return the computation, the result of the computation. So I can say if n equals 1, then return 1, because 1 factorial is 1. Otherwise, we'll return n times invoke f, n minus 1 specifies n. Now this is going to be a little bit confusing. And this is by far the most elegant version of the same logic of computing n factorial. Okay, and we'll just go ahead and say print invoke factorial, and we just want to find out what is the factorial of 3. Okay. What do you think of this particular pseudocode? This is the line that is the most complicated. We know how to deal with this one already. Returning a constant, hey, no big deal. We can return a product. That's no big deal either. But we have an invoke on the same line as a return. That's going to cause some confusion. Okay? But what you need to keep in mind is we are not changing the way we have been doing things since the beginning of this class. So keep that in mind. It may look confusing. It may look very different from the programs that we have talked about so far, but it doesn't change the rules. Okay, it doesn't change the way we do things. So we'll go ahead and save this one first as factorial using return value, and then we'll trace it. This time we do have comments because we have a conditional statement. But the conditional statement, the condition of the conditional statement is relatively simple, so we don't need a very wide column. Line number as usual, and we don't have any global variables in this case. And that's because by using the return statement, I am making use of the computation, the result of a computation right away. I don't have to store that value anywhere, just like before, like passing by reference. I don't need to store it anywhere anymore. All right, so we'll start with line 9. Line 9 is has 2 operations on the line. The first one is to invoke the subroutine. When the subroutine returns, I'm going to print the value returned by that subroutine. So that means I have to use return info, and that will tell me to go back to line 9 to finish up just the print of that line. At the same time, I have to specify the parameter n, which is 3, because we have 3 specifying parameter n over here. And that's how we set up the columns in this case. Any questions? This one should be okay. This one is fairly simple compared to the previous examples. Then we get into the subroutine. Go to line 3 first. N equals 1 is false because n is 3. 3 does not equal to 1. Then we go to else, which is continue execution on line 6. All right. When you look at line 6, approximately how many things do we have to do here?
3.
Well, 3 main things. Okay, there are actually quite a few things we have to do. If I really want to specify the order of doing things, the first one is to specify, to compute what is n minus 1. Then we can actually go ahead and do the invocation. When the invocation is all done, then we can perform the multiplication. When we're done with the multiplication, we can finally go ahead and perform the return operation to change the question mark of the return info cell to a particular value. Are we doing okay so far with analyzing that line and just realize how many things we have to do and in what order do we have to do those things? Okay, all right. So just as I said, we have to first evaluate what is n minus 1. Well, that n, or the n of n minus 1, refers to column D, the n that I already know. N has a value of 3, 3 minus 1 is 2. All right, that's fine. So now that we know we are using 2 to specify parameter n, we can all go ahead and invoke f again. So now we have to invoke f again. Well, that means we have to use return info again. But this time, where are we returning to?
N minus.
We're returning to line new
6.
We're still on line 6 because the invocation will basically just specify what number am I going to multiply with n, right? So that means when we come back, we will still be on line 6. The return would still have to be done. The n times something will still have to be done. Are we doing okay with this?
Because you have the return statement on the outside of the invoke, so
Yeah.
that's why you just go straight to return after the invoke.
Yeah.
That's what you're saying.
Well, we keep whatever is on line 6. We keep. We only replace the invocation that we are invoking right now with a question mark. In other words, it doesn't matter what line 6 is. We take whatever line 6 is, and we just say that since this is what we have to deal with at this point, only replace this portion with a question mark. Are we doing okay with this? Okay. But every time we invoke a subroutine, we also have to specify the parameter. In this case, n as a parameter has a value of 2. All right, so this is going to get a little bit crowded, so I will have to kind of dissect it like this, so we can actually see a little bit more. So, all right. So now that we remember where we are supposed to go back to, and we have already specified the parameter, we can go back into the subroutine because we are invoking f. So we start with line 3 again. N equals 1, it's still false because n is 2 at this point. So we have to go to line 6. When we get to line 6, we have to do pretty much the same thing, not exactly the same because n is now 2, so that means the new n is going to be 1. Very good. All right, so we'll do that. And after you remember where you're supposed to go back to when the subroutine is done, then you continue execution in the subroutine starting with line 3 in this case. And it still checks whether n equals 1. This time it is true because n as a parameter has a value of 1 now. Now. That means we go to line 4. Line 4 is return 1. What do we do again when we execute a return statement? We replace the question mark of the return info cell with the value that we're returning. Okay? But what if the return info cell is another return statement? We don't care. Okay? Don't look at the rest of that line. Focus on the question mark. Locate the question mark in the return info cell, replace it with the value that you're returning, and you're done. Okay? So this is the important part. Do not get confused because the return info cell itself specifies a return statement. That has nothing to do with executing the return statement itself. Are we doing okay? Separating the execution of a return statement as opposed to seeing the return statement inside the return info cell. Okay? All right. Oh, but tag is, I can do something better here. See, I can just say that this is just n, because anything times 1 is just that anything. Are we evaluating the return statement like this one here? We're not evaluating return n times 1. We are only executing return 1. So your job is just to replace the question mark. Do not do anything with the values or the multiplication or anything that seems to you go, well, but I can't do it now. Don't do it. It is not time yet to perform that operation. Are we doing okay so far? Because that's the most common problem, or the most common mistake, is that people will say, oh, but I can do certain things already because now that we know this is 1, I can carry out some computation. Do not do anything. Just replace that question mark and you're done. All right. So after line 4, we get out of the conditional statement. We get to line 8, which is the end of the subroutine. At the end of the subroutine, we use return info to tell us where we're going back to, which is line 6. And line 6 now looks like this. Okay, when we get back to line 6, this is what line 6 looks like. Okay, now for those of you who want to kind of avoid confusion and stuff like that, there's no hurting, in using the comments column to indicate what line 6 now looks like. Okay, so if you want to use this to clarify to yourself what line 6 looks like now, go ahead and use the copy and paste approach. Okay, now we have no use of these 2 columns anymore. So we just say that they're of no use anymore. They are now deallocated. Now we are back to line 6, but line 6 now looks like this. In other words, now it is time to execute return n times 1. Which n are we talking about? Which column?
F.
We're talking about column F because column H is gone. So column F is the rightmost column that is labeled n. So we are talking about column F, which has a value of 2. 2 times 1 is 2. So we are actually returning a value of 2. What do we do next? We replace a question mark, but which return info cell am I going to copy from? Column E. Okay? So we copy and paste this one over here. And since we are returning 2 times 1, we are going to replace the question mark with 2 times 1, which is 2. Are we doing okay so far? Because this really is going to be the most confusing part. If there's a confusing part of this program, this is the confusing part. Yep.
Why didn't you say return n times 1? Replace that last question mark. It says n times 2.
We are executing this, and this is the effect of executing that.
Oh.
So let me just put a little speech bubble here to clarify it. Okay, execute this statement. Yeah, use a smaller font. It's kind of dominating the whole thing. No! Just want to resize this one. All right. Okay. And in fact, I will order this. Okay. Number 1, execute that statement. And the result is this part here. Okay, so we'll go ahead and use an arrow, change the endpoints. Nope, that's not it. Change the endpoint. All right, where do we change the points?
There's an arrow tool.
It's a line tool. You can well, that's that way. That's also this way. And then we put another speech bubble here. All right. So this is step 2, which is the effect of 1. There we go. Change the font back to 10. And then resize that. How's that? Is it better or worse?
It's marvelous.
Hmm?
It's marvelous.
Okay. So I'm taking notes for you. And it's also recorded. But it is really important. This is really, really important. What are we executing, and what is the effect of executing that statement? This is what we are doing. This is the statement that we're executing. The result of executing that statement is this. Are we doing okay?
I think where I'm going screwy is in column G, you executed n-1 twice. I don't understand why you executed n-1 twice to take n from 3 down to 1. Or am I just completely off base?
Well, okay, the way we got from here to here is by executing line 4.
Oh, okay.
This is the result of the execution of line 4.
Then how did n get equal to 1? We subtracted 1 from 3. How did we execute? We found line 3 to be true, which is n equals 1.
Uh-huh.
But there's only n minus 1 involved there one time in line 9. So from the beginning, if we go in and we subtract 3, subtract 1 from 3, that takes us to 2. How did we subtract an additional 1 from that 2 to get to where n equal to 1?
I see. You mean how do we get to line 6 and pass 1 as n?
Yeah.
That's because when we get to line 6, we use n minus 1 to specify n.
Okay.
But in that statement, this n minus 1, that n refers to column F.
Right.
Column F has a value of 2. 2 minus 1 is 1. And that's why the new parameter has a value of 1.
Why did we go back and subtract 1 again?
Why didn't we go back to...
and subtract 1 again. Why did we subtract 1 from column F? The way I read that out.
Because this is not an assignment statement. It does not change the column. All it does is to evaluate what is 1 less than n. And that's it. I'm not changing n. I'm just saying either what is 1 less than n. Well,
Right.
n is 2, 1 less than n. 1 less than n is 1.
Okay.
So that's why that 1 is never stored, but it was used to specify parameter n.
Okay. I mean, my problem is that in there's no loop or anything else that tells us to subtract 1 from n. More than 1.
That is correct. We never did subtract 1 from n because we never store that back into the same column. We use the result to specify a parameter. So instead of using the same n and you see the value of n decrementing from 3 to 2 then to 1, we now have 3 n's at one point of the execution of the program. 1 has a value of 3, 1 has a value of 2, and the last one has a value of 1. Because we have 3 invocations, and parameters are allocated on a per invocation basis, and that's why we ended up with 3 parameter n's.
Right, and that's what I don't understand because I only see 2 invocations.
There are 3 invocations.
Oh, okay.
Yeah, I just scrolled it off the screen.
All right.
Yep.
Sorry.
That's okay. It's kind of the limitation of the font size that I can use on this screen, because if I use anything that's too small, then it's harder to read. All right. Well, we are now back to here. We are done executing the return statement. After line 6, we go to line 8, which is the undo Control Z. We go to line 8. Line 8 is the end of the subroutine. So we'll go do the same thing. We'll basically say that when we get back when we return from this subroutine, we'll continue on line 6, and then we'll also use this notation and say that line 6 now looks like that. Okay. And once we collect that information, we have no use of column E or column F anymore, so they will now be deallocated. And now our execution is back to line 6. But line 6 now looks like this. In other words, we are executing return n times 2. Which n are we talking about?
D.
Column D, okay. And 3 times 2 is 6. So we are returning a value of 6. What do we do when we return a value of 6?
Put the 6 in the question mark.
We replace the question mark with 6, right? So we replaced return info, the question mark of the return info cell with 6 here. And then we are done with the return statement. We execute this return statement, resulting in the question mark being replaced by a value. And after line 6, we get to the end of the subroutine, just like before. We do 2 things. One is to remember where I'm thinking, pepper spray would just, increase the screaming. So maybe I should not. Yeah. So this tells me that we have to continue execution on line 9. So line 9 is here, and to remind us, what line 9 should look like right now, we can use the comments column if you want to, but it's kind of optional because we can actually see from here. But once we utilize the return info cell, there's no need for these 2 columns anymore. So now they are both deallocated. And now we continue execution on line 9. And this was a bad idea because print 6 actually needs to indicate what it actually does too. So I'm going to have to use the comments column for that purpose. After we print the value of 3 factorial, we're all done. So this is, if you really want to study, this is a good example to study, because if you can understand this one, or redo it, just forget about sheet 2, use sheet 3 to do your own trace. If you know how to trace this, and every step along the way you can clearly think in your mind, I know exactly what we should do here, I know exactly what we should do here, instead of, well, I'm kind of guessing we should do this. Okay? If you know exactly what to do, this is a good program to make sure that you understand the concept of returning a value. Okay? Okay, we have 5 minutes left. Not quite enough time to do another topic. However, we can talk about factorial. Okay, we can talk about how you can use factorial in your daily life. Okay, this is not a math class, not a statistics class, but some of you will find this useful. Okay, what is super lotto?
Lottery.
It's lottery. Okay, so lots of money. Oh, the question is it really a lot of money? How do you compute your chances of winning super lotto?
Your chances are like 1
It's,
out of a million.
Okay.
NCN.
Okay, we'll go ahead and do some real quick calculations here. Yep.
I was gonna say, isn't it like, let's say, I don't really know, I've never played the lottery before, but let's say you pick 6 numbers.
Out of what?
It's
It's 6 numbers out of how many? Sorry?
Are they 2 digits?
32?
No, 2 digits per number.
2 digits per number, but the numbers don't go all the way to 99.
Yeah.
They draw the balls from a cage. So how many balls are in the cage?
37 or something?
37? Okay, let's say 37.
Yeah,
And
it's
we pick 6 of those, right? So you have 37 times 36 times 35 all the way. So you have, okay, let's just finish the multiplication. 34, 33, 32. And I think, is that 6 numbers? Yeah, that's 6 numbers. And then there's also a extra number, right?
Oh yeah, the super number or whatever that you
Okay.
have to get to win anything.
Right. So there's an extra number, and the extra number cannot be one of. Can it be one of these 6 numbers?
No,
Or it has to be
it
a
can't
different
bring
number.
the-
Hmm?
Everything. It could be the same number.
Can be the same number?
Yeah, so it's
Okay, if it can be the same number, you have to multiply 37 because you cannot reduce the number of choices for that particular number. Okay, so these are the total. This is the total number of possibilities. Okay, doesn't look too big. Well,
It's actually 56.
million something.
Or is it?
Okay, so let's say this is 50 million. Okay, let's say this number turns out to be 50 million, which means if you buy 50 million tickets, you have a good chance of actually having one to match the number. The next question is, how many people will think like you? A lot of people, right? So that means when there's a jackpot, probably multiple people would hit the jackpot, especially when the jackpot is really high and everybody thinks, hey, the prize money is 50 million and the chances of winning is 1 in 50 million. So if I spend $1 to buy a lotto ticket, my chances are even. Well, not quite, okay? Because you're also forgetting state tax. Okay? What is the percentage of state tax?
Like half of it, isn't it? 50%.
When you don't have money, it's not that much. When you have $15 billion, it's not that little. Okay, so you have to factor in multiple people can win at the same time, and you have state taxes.
And then there's the lump sum
The lump
where
sum,
they take like
Yeah.
a third of it away
right?
if you get it all paid out at once.
Yeah, if you don't get it over payments.
Yep. So that means you need the prize money to be up in at least $100 million to even worth considering. When does it ever the jackpot get to $100 million? Rarely, right? Why? Why do they make it so hard to win? Why do they make it so that you always lose on the average?
So they can make money.
So that we can have classes here. I'm not kidding. Lotto money gets funneled into the community college systems along with K-12.
It's
Yep.
supposed to.
And the bad thing is, they have people like me telling people about all these things, and that people do not buy lotto anymore. So in the end, I would just, I would teach myself out of a job because there won't be money back into the system anymore. I should be promoting it, exactly, not teach this stuff, right?
Everybody
Alright.
should go out and buy a lotto ticket right now.
And we still have 20 seconds left.
Okay, very good.
Let's do another
There's
one.
just enough time to walk into class. How you doing?
Alrighty, I'll see you guys next Tuesday. Have a nice weekend.
Yeah, I don't think it's state that takes it out.